Hey guys, we're continuing with part 14 of our Regents Review series. It says, base your answers to questions 16 through 18 on the diagrams below and on your knowledge of earth science. The diagrams represent three sedimentary rock outcrops labeled 1, 2, and 3, found in the northeastern United States. The outcrops have not been overturned. Some rock layers contain New York State index fossils. One unconformity has been labeled X. 16. Identify the names of two index fossils found in these rock layers that represent organisms that could have been alive at the same time. So the answer is Cryptolithus and Valcoroceras. But you can write B and D because those are not the names of the fossils. You need the actual names, and you can find the names in your reference table. Find all of these symbols, and if you go on your reference table, page 8 and 9, in the bottom of the reference table, you have to look at it side by side, page 8 and 9, and you'll see that these fossils represent these names and these letters B, D, L, and R. And if you find these index fossils, these are the time distribution of fossils in New York. You'll see here's B and D, here's L, and here's R. It looks like B and D were alive around the same time, around the Ordovician period. And B and D are Cryptolithus and Valcoroceras. Number 17. Good index fossils are often abundant or easily identified. Describe one other characteristic of these fossils that make them index fossils. The correct answer and acceptable responses include, but are not limited to, these organisms only existed for a short time, or these fossils have widespread distribution. Um, and you can actually find this in your Regents Review packet. I don't have it in this picture right here, but you can find it in your Regents Review packet for a geologic history. Um, Index fossils exist for a short period of time, and they're widespread and they're abundant. They're short lived, widespread, and abundant. Number 18. Identify by name the sedimentary rock layer that is missing from rock outcrop 3 due to the formation of unconformity X. So, for this, if you want to know whether some layers are exist around the same time as other layers in different locations, or some layers are missing, you have to start from the bottom of each layer and you have to find a pattern between each outcrop and see whether that pattern continues as you go up. The more you see that pattern continue as you go up, the more likely it is that your patterns or your sedimentary rock layers that you're looking at that match the patterns are existed around the same time. So if I start from the bottom, and by the way, outcrop 1, 2, and 3 may have been joined together at one point. That's why they might have some existing sediments that are existed around the same time when they were deposited, but eventually a lot of times these outcrops start to separate because of plate tectonics and new sediments start depositing. And then these unconformities, the squiggly lines, show that these areas might have been eroded and new sediments might have been deposited, so we might be missing some rock layers. So if I start from the bottom for 1 and 2, and you can start anywhere, I'm starting and comparing outcrop 1 and 2 first. I see that these two layers match, and then we have an unconformity X in outcrop 3, so we might be missing a layer. And that layer might be this layer. If I continue to look as I go upward, I see that this layer matches this layer. And then this layer is non existent here because there's an unconformity, but then afterwards, this layer matches this layer. And then we have an unconformity here, so this might have been removed. And then we have an unconformity here, so this might have been here but it got eroded away. So this is very promising for me because a lot of the sediment layers are starting to match up between 2 and 3 as I'm going up. So it seems like these two are probably around the same time and so on, and these two were existed around the same time, meaning that unconformity X, because of this layer right here in outcrop 2 might have also existed in this layer, but because of unconformity X, that layer is missing because of erosion. So I need to figure out what this layer is or what type of sedimentary rock this layer is. And if you go to your reference table, page 7, and find the symbol in the sedimentary rock chart, you see that this is actually limestone. That's why the answer is limestone, because it's asking about what type to name the sedimentary rock layer that is missing. That's it.